students. Hope you went through the previous topics, dispersion, formation of rainbow, right? In the topic of formation of rainbow, I had told you something regarding total internal reflection. That is when the 7 band of colors enter the water droplet, it gets totally internally reflected, right? Now, what is this total internal reflection? Let's see. Right. Just consider you have this is a denser medium. Let's consider this as glass medium. This is a denser medium, and this is a rarer medium. Okay. Now, when a ray of light is passing from a denser medium, from a rarer medium to a denser medium, where does it go? This is the ray of light. What do we do at the point of incidence? At the point of incidence, we draw a normal. As it is going from a rarer medium to a denser medium, what do we do? Where does the ray of light get reflected? It gets, not reflected, refracted. It gets refracted towards the normal, right? This is the way it's going to refract it. But along with refraction, there's one more phenomena that takes place that is called as partial reflection. Okay. Now, when this yellow colored ray of light is touching the surface of air and glass, part of the light, part of the intensity of light is reflected back into the atmosphere, and part of the ray of light is refracted. So this is the reflected part. Now, the reflected ray of light will follow the laws of reflection. What is the law of reflection? That is, angle of incidence is equal to angle of reflection. This is angle of incidence, this is angle of reflection, and now this is your angle of refraction, right? So when light enters rarer medium from a denser medium, it gets partially reflected. Now, this was rarer to denser. We'll have another scenario which tells us denser to rarer. Okay. Now, again, this is a denser medium. Denser medium. This is a rarer medium. Now, a ray of light is passing from a denser medium to a rarer medium. From here, this is the source of light. This is touching the interface. This is your normal. Now, when it goes from denser to rarer, where does it move? It goes away from the normal. Now it is going away from the normal in this way. So when it goes away from the normal, along with getting, as it happened in the previous case, it happens in this case also. Part of the light is refracted, part of the light is reflected in this way. Again, it will follow as per the laws of reflection. So this is your refracted ray, this is your angle of refraction, this is your angle of incidence and angle of reflection. Here, angle of incidence will be equal to angle of reflection. Okay, this is as per the laws of reflection. Now, part of the light is refracted in the rarer medium and part of the light is reflected inside the denser medium. Now, this is called as partial reflection. This is called as partial reflection. Now, consider a situation. Now, in this case, if you see, it is going from denser to rarer, so angle of refraction has to be more. So this R dash is greater than I, angle of incidence. And if, for example, if the angle of incidence is 45, angle of refraction would be 60 degrees because it is moving away from the normal, right? Now, if I increase my, for example, for 45 angle of incidence, I get an angle of refraction of 60 degrees. If I make this angle to be 60 degrees, I'm going to get here, this is only I'm taking as an example, okay? This my angle of refraction would be 75. This is angle of incidence. This is R dash angle of refraction. If I go to 75 degrees, it might happen that my angle of refraction would become 90 degrees, right? So I'll take this situation over here. This is my incident ray. Now this angle of incidence over here is 75 degrees. Okay, so when I take an angle of incidence of 75 degrees, this is my refracted ray. So now see the angle over here. This is 75 degrees. My angle of refraction would be 90 degrees. Now what will happen after this? Even here also, part of the light is getting refracted and part of the light is getting reflected inside the block. Now, when I increase my angle of incidence more than 75, for example, if I go to 80 degrees, Okay, my angle of refraction would be more than 90 degree. Right, my angle of refraction would go more than 90 degree. So when it goes more than 90 degree, all the light rays, okay, all the light rays will not go into the rarer medium, but it will get totally internally reflected inside the denser medium only. Okay, when this happens, this is called as total internal reflection. Right, let's do this in detail. See, now we'll go step by step. Right, first step, when light enters a rarer medium from a denser medium, we know where it goes away from the normal. So this is your angle of incidence, this is angle of refraction. Theta I, that is your angle of incidence, would be less, angle of your angle of incidence is less than angle of refraction. Okay, next step. Now, when we go on increasing the angle of incidence, what is happening? Angle of refraction is also increasing, right? So initially I took as 20 degrees, it is 27. Then I took the angle of incidence as 30, it went to 42. Refraction, I took the angle of incidence as 40, my angle of refraction went to 59. Now, in this way, I am going on increasing my angle of incidence, and at a particular angle, at one particular angle of incidence, I am going to get my angle of refraction as 90 degrees, right? Okay, now why is this happening? This is happening because of your Snell's law. What does this, is the refractive index of this pair of medium changing? This is, you can consider this as glass or water, and this is as air, right? It is not changing, as the refractive index is going to remain constant. And we know what is refractive index. It is sine I upon sine R. So this is your refractive index. This is also constant. So according to Snell's law, refractive index has to remain constant. Even if I is changing, R has to change. So that's why this phenomenon is taking place, right? So when we go on increasing the angle of incidence, sometimes at some particular angle of incidence, my angle of refraction is going to be 90 degrees, right? This, at this angle, what I'm getting, this angle of refraction is getting 90 degree. Now this angle of incidence is called as the critical angle. The angle of incidence at which my angle of refraction is 90 degrees, that angle is called as critical angle. Okay, keep this in mind. We'll proceed to step 3. Now, see, this was which I was talking about. At a particular angle of I, angle of refraction is going to be 90 degree. This value of I, critical angle, is called as critical angle. This value of angle of incidence is called as critical angle. So a 1 mark question can come, define what do you mean by critical angle. So a critical angle is that angle of incidence at which angle of refraction is 90 degrees. That is called as critical angle, right? Remember this. Can easily come for a 1 mark question. Okay, now what after this? Once your angle of incidence becomes equal to critical angle, okay, after this, when your angle of incidence is greater than critical angle, already at critical angle, the refracted ray is grazing the surface. Okay, so if this is your block, this is my angle of incidence, refraction, and this is the way the refracted ray is going. That means it is grazing the surface. Sometimes it is also called as grazing refraction. Okay, it is also called as grazing refraction. Now, when I increase, this is my angle of, this is my critical angle, and this is angle of refraction is 90 degree. Now, when I increase my angle of incidence greater than the critical angle, what will happen? These light rays which were getting refracted, they won't get refracted, and they will be reflected inside the denser medium itself, following the laws of reflection, that is angle of incidence equal to angle of refraction. For water, sorry, for glass, critical angle is 42 degrees for glass. Okay, so when I hit a particular ray of light greater than 42 degrees, that means if I hit a ray of light, if the ray of light is incident on the glass surface at an angle of 45 degrees, this ray of light is going to get totally internally reflected. It will not go outside the surface, outside the denser medium, it will to the rarer medium. Okay, another one more thing to remember, total internal reflection is only possible when the ray of light is passing from a denser medium to a rarer medium, right? It won't happen when it goes from rarer to denser. It will only happen when it goes from denser to rarer, and the reflected, internally reflected light rays will get reflected inside the denser medium itself. The same way, now I'm connecting this to the formation of rainbow. This was the water droplet. The rays of light from the sun hit this surface. At this surface, now this water droplet is acting as a prism. Dispersion took place. This band of colors took place. Now, at this particular surface, total internal reflection, that is TIR, total internal reflection is also sometimes called as TIR. So, TIR took place. That means the angle of incidences of these 7 band of colors were greater than the critical angle for water. Okay. Now, these rays got totally internally reflected and they came out like this, and then we got the band of 7 colors. Okay, so this is the way total internal reflection happened in rainbow. Now moving ahead, for angle of incidence is greater than the critical angle, the angle of refraction will be greater than 90 degrees. Yes, when this happens, when the angle of refraction becomes greater than 90 degrees, this is 90, this is greater than 90, this becomes totally internally reflected. Such rays return to the denser medium. All these rays get reflected back into the denser medium. This is called as total internal reflection. Understood? Okay. Now, when does total internal reflection takes place? Now, there are certain conditions then or there only. So, okay, just to summarize all the topics, see, this is the source of light. Okay, you know, whenever a ray of light hits the surface perpendicularly at normal, it goes without any deviation. So when it is hitting at 90 degree, it will go without any deviation straight into the air. Now what is happening? Now here my angle of incidence is 0. Now I'm slowly I'm increasing my angle of incidence. This is my refraction. Again, I'm increasing the angle of incidence. My angle of refraction also increases. Again, in the third one, I'm increasing my angle of incidence. Now the angle of refraction I'm getting is 90 degree. So at this point, my angle of incidence become IC. What is IC? IC is your critical angle, right? So now when my angle of incidence goes greater than the critical angle, your angle of incidence greater than critical angle, the entire light rays will get totally internally reflected in the denser medium itself. Till here, till 1, 2, 3, what was taking place? Partial reflection was taking place. That is, some part was getting refracted, some part was getting reflected. This is partial reflection. But when it achieves this condition, that angle of incidence becomes greater than the critical angle, all these rays are internally reflected itself. It goes inside over here itself, right? So this phenomena is called as total internal reflection. Very important, what are the conditions under which total internal reflection will take place? Number one, the ray of light should always pass from a denser medium to a rarer medium. Then only total internal reflection is possible. Another important thing, your angle of incidence should be greater than the critical angle. Angle of incidence, when it becomes greater than critical angle, then only partial reflection will stop and total reflection will start, total internal reflection. What is critical angle? It is that angle of incidence for which angle of refraction is 90 degrees. Again, the same phenomena explained over here. If the incident ray is increased beyond the critical angle, the light is no longer refracted. Instead, it is reflected back inside the medium. What is this? This is called as total internal reflection. When incident angle is greater than the critical angle, there is no refracted rays. All the emergent rays are internally reflected. Again, the same thing explained point by point. Understood? So this was the entire phenomena of total internal reflection. Next, we have very interesting, again, all the natural phenomena that we see around us, that is atmospheric refraction. Now we will understand what do we mean by atmospheric refraction, or from what is the source of light for Earth, right? The source of light for Earth is basically the sun. Whatever light and heat which we are getting on the Earth is because of sun. Now these rays from the sun, it has to travel such a high distance, vacuum, and so many kilometers of distance, and then it comes in contact with the atmosphere of the Earth, or it directly reaches the Earth. Obviously, we have a big layer of atmosphere above the surface of the Earth. So when it enters the atmosphere of the earth, something interesting happens. Okay, we will see what is that interesting thing, and based on that natural phenomena, so many other related phenomena are there. Okay, so again, next episode is going to be very interesting. Stay tuned for that, and hope you understood the basics of total internal reflection. Thank you. Stay tuned. Bye bye.